Alright, I welcome you again to today's lesson. Previously we looked at ways of finding areas on a topographical map, where we looked at finding an area of a regular object. Today we are going to look at finding an area on a topographical map, but of an irregular object. We have an example of our irregular object here. An irregular object can be a seasonal swamp, anything that is not having a definite shape. So we looked at how we could find the area of a regular object on a topographical map. Today we are going to look at finding the area of an area which is irregular on a topographical map. But remember the other time we talked about methods how we can find this. If the area is irregular, that means there is no shape, there is no formula we can use there. So we want to find ways of finding the area of this using some methods. Because we don't have a direct method of finding the area here, since the area is irregular, we don't have a formula for this. But there are ways we can use or we can pass through to find the area covered by this. So one of the methods we can use is grid square method. Grid square method. Grid square. Grid squares. These are the squares, because remember these are grids. This is grid references. We talked about them, eastings and northings. So meaning this one, a box which is made up by northing and eastings, this one becomes a grid square. This one is 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 a grid square. So we are going to use these grid squares to determine the area of an object which is irregular. That's why we call it a grid square method. So this one, using a grid square method, an area is going to, we always use a simple formula where it is complete squares plus incomplete squares divided by 2. So we count the number of complete squares plus the number of incomplete squares divided by 2. Here we divide by 2 because you may find that the reason as to why we don't divide by 4 or what, you may find that an area is covered by a quarter, another grid square is covered by a half, another grid square is covered by 3/4, 3 quarters. So now there is no way you're going to get these ones which are incomplete. You get a quarter square plus a half square, and there is no way you can determine that this is quarter or half. That's why we use average, that whatever is not full is incomplete. Be it a halfway covered, be it quarter covered, be it 3/4 covered, but it is still incomplete. So we use 2 as the average, that whichever square which is not full. Now for example, you look at this one. The area that is covered by the stone swamp over this box is not the same as this. But the point remains, this is incomplete and this is incomplete. So what is not complete is incomplete. So it is either full or a half. That's why we divide by 2. So this 2 is the average to cover for incompleteness of a box. So here what you have to do is check the area that is covered by this feature. Look for the complete squares. So here you must be careful. Even if it has entered by 2 dots, because 2 dots on the map looks small, but on the actual ground it is big. Why? Because on the actual ground, 1 centimeter represents half a kilometer. Meaning 1 centimeter on the map represents a kilometer. So every 1 centimeter box represents half a kilometer on the ground, meaning even if it has entered by 2, that is big area on the actual ground. So here what we are going to do, we are going to count complete squares, number of complete squares. Here we have only 1. You mark it as 1. We have 1 square. Then incomplete, here we have, you count, we have 1, we have 2, we have 3, It has entered 8 here, it has not entered, don't count that one. 9, 10, 10, here it has not entered. So we have 10. There are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 incomplete squares. So meaning, here we are going to have our map area as 1 square plus 10 divided by 2, because remember I said incomplete squares divided by 2, which we shall get area as 1 plus 5. Now because of the half, these ones now become complete. Why? Because the halves have been joined together to get now complete. So here we shall have area equal to 6 greedy squares. So we have roughly 6 greedy squares. So we assume that this feature approximately occupies 6 complete squares, because here the squares are all full. So these ones which have been covered partially by the object, we try to compress, to put them together, to join them together to make a complete square. So assuming we are having 6 greedy squares, the area covers approximately 6 greedy squares. So now I want to find out a greedy square. What does it represent on the actual ground? In other words, we want to find out, because this area must be in kilometers. 1 centimeter represents half a kilometer. So we want to find out every square represents what, such that when we put those squares together, we can get the actual ground that is covered by that area. So here we are going to look for these squares. We want to find out area per greedy square, greedy square. So we are going to bring out one box here. Remember, these are 6 greedy squares. So now we want to find out, we want this area in kilometers. So, but we should know the area per greedy square. This is what we are doing. So we know that, as I told you, that the standard maps here we use, map extracts, 1 centimeter, and another is one side of a grid box is 2 centimeters. So meaning here we have 2 centimeters. If that is the case, that means here this is 2 centimeters, this is 2 centimeters, this is 2 centimeters. But previously we got how to convert from representative fraction scale, representative fraction, to statement. Now we know how to convert. That 1 centimeter on the map represents half a kilometer on the actual ground. Meaning this one is the same as this scale by statement is the same as 1 centimeter to half a kilometer. Using the previous lessons, we looked how we got how we can find out this. So if that is the case, we want to find out the actual ground area per grid square. This one is going to be area of a square is S squared. That is the area of a square. So area is going to be 2 centimeters times 2 centimeters. That is S squared. Side squared. That means one side is 2 centimeters, another one is 2 centimeters. When you square them, you get this. So our area actual is going to be 2 times a half a kilometer, because where there is a centimeter, we put half a kilometer, times 2 times a half a kilometer. This and this one disappear, this one and this one disappear. We shall remain with 1 kilometer times 1 kilometer. 1 kilometer here, 1 kilometer here. That means area per grid box, area per grid square equals 1 kilometer squared. After getting that, we go back to our feature. We said that our feature area, the map area of our feature is 6 grid squares. And now we have already got a grid square weighs what? So our area is going to be 6. Where there is a grid square, here we shall put what a grid square represents on the ground, meaning 6 times kilometer square, because every square is 1 kilometer square. So these are 6 grid square. This is the grid square. Hope you are getting it. So meaning our area is going to be 6 kilometers squared. The area that is covered by our seasonal swamp is 6 kilometers squared. Some students have a tendency of just getting the grid squares here. They know that here we always get 1 kilometer squared and they say 6 kilometers squared. No, you have to measure. You may find that once we change this, if I bring to a map whereby the grid box, I'm giving an example, they can change. This one works when the map is 2 centimeters, but the examiner would need to see the working. How did you convert up to 1 kilometer square? But it may change. If this square is not 2 centimeters, let's assume the square is, now the side is 1.5, 1.5 centimeters. Let us see. If that is the case, that means this 1.5 centimeters, this is 1.5 centimeters, this is 1.5 centimeters. So area is going to be 1.5. Remember, where there is a centimeter, we put a half a kilometer, because our scale is 1 centimeter representing half kilometer, meaning times a half a kilometer. I'm getting the actual ground area per grid square, times 1.5 times a half a kilometer. So here you'll find that here it was 1 to get 1 kilometer squared from this one. This one came from this. But now here it is not the same. Here we have 1.5 kilometer divided by 2 times 1.5 kilometer divided by 2. Here you don't get 1. Remember, it is 1 kilometer squared that we multiplied with what we had got as our grid square, total of grid squares. So meaning here, if I just cram, here it is going to be wrong. Here, I'll not get 6 kilometers squared. If I get 1.5, I divide by 2, I get 1.5 divided by 2, I'll not get 1. That means what I get here, when I multiply it with this, it is going to change this. It will not remain 6 kilometers squared. But still, if I change the scale, even if I leave the side of the box to be 2 centimeters, but I say, now let's assume they have changed the map extract they have given to you is 1 centimeter representing 100,000 kilometers. It will not still be the same here. Why? Because 1 centimeter will not be representing half a kilometer. Here 1 centimeter is going to be representing, for example, if we change this, we know that 1 kilometer equals 100,000 centimeters. If that is the case, how about 100,000 centimeters? They represent what? This one is constant. This one, we should find out that every 1 centimeter represents 1 kilometer. So if 1 centimeter represents 1 kilometer, that means it is not the same as this. So meaning, if I get 2, I'll multiply it by 1. I'll get 2 multiplied by 1, not a half. So the answer will still remain not the same. So those students here, I encourage you not to cram. You have to measure. Every map given to you, check, is the side this 2 centimeters? If it is not 2 centimeters, don't cram, then do accordingly. Is the scale 1 centimeter representing half a kilometer? If it is not, then do accordingly. Don't cram. So this is how we can find the area of an irregular object using grid square method. Thank you for attending today's lesson. I urge you to practice this. Practice map work. Map work is practical, so you have to do practice. Get map extracts and try to discuss, try to pass through these things practically. You will find map work easy and enjoying. I urge you to subscribe to my YouTube channel, Learning at Ease, for more lessons, for more knowledge, and on my Facebook page, still Learning at Ease, for more about geography. Thank you for attending.